4 buses in the system. All the 4 buses, if you look back, will have a Y bus of the dimension 4 cross 4 in this problem. So look at the bus number 1. How is the connectivity? Where all bus number 1 is connected to. Look at the bus number 2. Where all it is connected to. Look bus number 3, 4, etc. Looking to that visually by rule of inspection, I can frame Y bus for this particular problem, which is already shown on the board for your representation. Y bus, the first row refers to understanding of connectivity from bus number 1. 1 to 2, there is a line, and 1 to 3, there is a line, and Y11 refers to sum of the admittances of the line radiating from bus 1 to 2, bus 1 to 3. That is being taken as a grand sum at the diagonal 1 cross 1. So called 1 cross 2, which is called as an off diagonal element of a Y bus, which is negative of the admittance of the element between 1 and 2, which is given in the first row, second column as -2 plus J6. In fact, the value of elemental data of element 1 to 2 is in the table 2 minus J6, whose negative if I take, naturally it becomes -2 plus J6, which is 1 cross 2. Next I have 1 cross 3, row number 1, column number 3, which is the element between bus number 1 and 3. Yes, there is an element which is given as by the data 1 minus J3, whose negative is -1 plus J3. And there is no line connected between bus 1 and 4, hence it is 0. Similar to this, looking at each bus, how many radiating transmission lines you find from that bus to the rest of the buses, add the admittances of all those. Put it as a grand sum at the diagonal of that particular row. 2 cross 2, the diagonal of bus number 2. 3 cross 3, diagonal pertaining to bus number 3. Similarly, 3 cross 3, like that, and 4 cross 4, which you find on the board. As well as the off diagonals are the negative of the admittance between the particular bus you are considering to the bus where it got connected. That you will come to know from the connectivity which is mentioned in the diagram or in the table of connectivity 1-2, 1-4, 1-3, like that. That connectivity which is mentioned, which will help you to take out what are the off diagonals of this particular problem directly. So, having viewed those connectivity, we have framed the particular value Y bus in the form of matrix 4 cross 4, which is very necessary for us, because when we want to obtain voltage solution of this particular problem using GSLF method, we come across the solution of voltage by equation which was mentioned in this board. You can see here V2, a solution of bus voltage 2 at the end of iteration number 1, which is written as V21, which is 1 divided by Y22. If I pronounce in terms of arbitrary way, V2K of iteration R plus 1 or R, which is equal to 1 by YKK, Pk minus JQK over Vk0 conjugate minus summation of K1 to M not equal to M Ykm into Vm. That was an expression we had in the derivation. That expression was used here to write the possible voltage solution at bus number 2 is established with 1 divided by the diagonal element Y22, 2 cross 2, this element, into the bracket inside. The power situation, active power situation at bus number 2. What is this P2, Q2? P2, Q2 are the table of information mentioned here. Can you see over here? Bus number 2, when I come and stop with the PI column, 2 is having 0.5 PU active power situation. PI is called as net situation. It may be, there could be a generation and there could be a demand. Generation minus demand is nothing but active power situation. PG minus PD. Likewise, the demand, the QI value is 0.2 minus. What this QI refers to? For this position as a substitute. This refers to QG. Is there any generation of reactive power at this bus? Is there any demand on this bus by reactive notation? QG minus QD. Net differential value is the one which I have to write here. This P2, Q2 in case of bus 3, P3, Q3. In case of bus 4, P4, Q4, I am going to pronounce. What that P2, P3, P4, P4, whatever so-called number refers to, that refers to active power situation at that bus. Similarly, reactive power situation at that bus. What is that reactive power and active power situation? It is the net generation at that bus minus the demand at that bus by active power value, difference of that value is P2 for bus number 2. Similarly, reactive power generation Qg2 minus Qd2 demand. That differential value is called Q2. So this way, these values must be identified. For me, this problem is very simple problem which I have taken as directly Pi, Qi, Vi. The values to be referred at respective bus are directly given in the problem. I mean, this Pi, this Qi, so-called other, I will be just taking and placing in the respective equation. This is a quite simple problem which you have initiated with the beginning. When I go to the next problem, I need not have this kind of situation. I may be having demand and generation in side-by-side column. I have to do numerically a difference, Pg minus Pd, and find out that value, locate here. Qg minus Qd, find out the difference, place over here. This could be a work for me when I have another type of problem where the calculation of Pi, Qi, I may need to do it. For me, in this problem, it is ready to go. Pi is given, Qi is given as 0.5 and minus 0.2. I will just position over here. That you could see here. 1 by y22, I picked here and placed here. And P2, Q2, what I got here? 0.5 minus 0.2, I place here. 0.5 minus j, inside this bracket Q2 value, 0.2 minus. Divided by, what is this? This is called as initial estimate of variable 2. What is V2 of 1? I am trying to get the best solution of voltage of bus number 2 at the end of iteration number 1. That is my hunt. Before I begin to compute the best fit value, I should have an initial estimate for the need of Gauss-Seidel method. That is called as initial estimate or initial assumption of variable. That is called as V2 0. Here V2 1 means best fit value at the end of iteration 1. This refers to V2 0, initial estimate of variable 2 or bus voltage 2, which is given as by a condition flat start. When the word flat start is used, it is to take the care that the particular value is 1 angle 0 or 1 plus j0. It is called as 1 per unit and angle is 0. In that regard, V2 0, can you see over here? 1 angle 0 and a conjugate is written by star notation. Minus these terms. How many terms will be here? I was speaking in the earlier interaction. From the bus 2 perspective, you look from bus 2, how many connections are there to the other buses? 2 to 1, Y21, one term will come over here. Y21 with what voltage? From bus 2, where it will land? 2 to 1, 2, 1, V1. If it is Y21, V1 is an indication of this connectivity. Similarly, 2 to 3, Y23, V3. Can you see over here? Y23, V3, 0. Why it is V3, 0? Why not it is V1 of 0? V1 is nothing but flat bus voltage, which is given in the problem. Bus number 1 is having the scheduled voltage 1.04 and angle 0, which is given in the problem, which you are not going to tamper. You are going to refer what is the constant given over there. Therefore, it is not going to change any way in any of the iteration when I go next iteration by chance. This slack bus voltage is not going to change. We are going to hold it constant as given in the problem. Hence, it is 2 to 1 V1, 2 to 3 V3 0. V3 0 is like V2 0 initial estimate of bus number 3 variable. Yet, I have not at all calculated voltage of bus number 3. I am just in the process of V2 of 1. Likewise, V3 of 1, V4 of 1. I have to calculate it. Have I done it? Still not. Therefore, Y23 is the connectivity from bus 2 to 3, landing with the voltage 3, V3, it is the initial. because I have not yet computed the best fit value of bus 3 at the end of iteration 1. I haven't reached bus 3. Still I am at bus 2. Therefore, the initial estimate of bus 3 is V3 0 minus. What is next connectivity? 2 to 4. When I have 2 to 4, Y2 4, V4 0. It is same as V3. V3 is yet to be computed. Similarly, V4 is also yet to be computed. Therefore, V40 is referred. Once I will find how many terms are there. 1, 2, 3, 4. You check and see how many terms are there in the row number 2. 1, 2, 3, 4. Physically, you will find 1, 2, 3, 4. Leaving this term, these are called mutual terms. From leaving this central term, how many you have? 1, 2, 3. There are 3 connectivity. Y21, one connectivity. Y23, second connectivity. Y24, third connectivity. So this row is witnessing you what will appear in the equation. No need to remember this. You remember what I should present in the equation which quantify my required voltage. So therefore, for that Y bus refer Y bus and make it convenient. Then I substitute the values. Can you see over here? 1 by Y22, P2 minus J22 from the table of information which is given, and Y21, capital Y21. What is this capital Y21? It is the admittance between 2 and 1, row number 2, column number 1. If I go here, row number 2, column number 1. What is the value here? Minus 2 plus J6. This is taken and it here. So some book refer, instead of capital Y21, there is lowercase y21. What is lowercase y21? Elemental admittance. What is the difference between capital Y21 and lowercase y21? 1 minus. When I write capital Y21, it is already negated, which is in the elemental representation here. If I write lowercase, it would be plus at that time. That's the difference. Therefore, standard when I refer with respect to books, capital notation refers to elements from admittance bus. Lowercase letters to elemental admittance primitive values, which require one additional term. Therefore, so let us look into this. Whenever I come across problem, when I solve, I will convey you once more what care you must take. Okay, capital Y21, I pick and place. Then what is V1? V1 is given as 1.04 angle 0. I mentioned here. Next, second term minus Y23. Where is available? Second row, third column. This is picked and pasted here. And what is V30? Because of flat start, I haven't taken any computation. Because of flat start, it is 1 angle 0. 1 angle 0. So next term minus Y24. What is Y24? Second row, fourth column. Y24. Pick and place into the flat start voltage of V40. Which if I place, if I make a bracket complete, operate and compute it with the help of calculator, I will be able to get the value of complex voltage at bus number 2, V2 at the end of iteration 1 as 1.019 plus J.046 per unit. Suppose in the example, in the numericals which you are going to solve, obtain the value of the voltage at the end of iteration 1 means this is your landing point for voltage 2. If they want to, anyhow, in the syllabus it is mentioned 1 iteration. If it is 2 iteration, what should be done? This set of work I have to repeat for set 2 means V2 of 2, V3 of 2, V4 of 2, like that. Iteration count has to go next. So for us, we have only 1 iteration, hence we will not be worrying about it. V2 of 1 refers to this way. Now if I work again, next bus V3, what may be my change here? In this position, if I rearrange, what may be the V3 of 1? Similarly, this right hand side also, I will change. Let us do it. So, hope this V2 of 1 is convenient with you, which requires calculation. I am alerting you, this is not simple. In the complex mode, in the calculator, you need to work it out. Open appropriate number of brackets. Take proper care when you multiply the term, because you have a mathematical product division and differences and addition you have. So BOD-MOS rule comes out here. Therefore, suitable number of brackets Open, close, you need to do, or else you take a product, simplify. Take a product, simplify. Take a product, simplify. And simplify. Then simplify and come out. So once you need to try, then only you will get a confidence. I am quite sure if you have been said to do this with your calculator right now, I am sure many of you will get different answers from your other friends. It is because your involvement in doing this computation matter over there. So a mere practice can make you perfect over here. Okay. Anyhow, I will be sharing these things already. I have shared yesterday. I have to accept your admissions to my Meet, Teams accept. Then you will be getting all the downloads readily to you. So these things you have to take care. This is for V2. Let me do it for V3, V4. Then you will get a confidence. So let us take V3. So if I make it V3, may I know it? So I make it. Let me write it. I make it complete in me. It will be very convenient for you all. Now I make it V3 of 1. What may be the expectation of solution of bus 3 voltage at the end of equation number 1, which is likely cyclically. If I write it Y33, you follow me, P3 minus J Q3 over V30 conjugate minus Y31 P1 minus Y32 V2 of 1. You please note the change which I wrote here. Y34 V4 0. Hope you are able to see this change. V3 of 1 is solution of voltage of bus number 3 at the end of equation 1 is 1 by Y33 inside the large bracket active power situation P3 minus reactive power situation divided by the same variable what you are trying to estimate, whose initial estimate V30 conjugate, V30 conjugate minus all the possible connection from bus 3. So you can turn back and see from bus 3 to 1 there is a connection, Y31. I wrote here, Y31 with a voltage where it lands 1, V1. And I have Y32, Y32, V2, 1 I wrote here. You must notice this superscript, 1. Why I wrote 1, why not the 0? 0 means initial estimate. Do you have two values for V2 now, right this time? Yes, you have two values. One was initial estimate, 1 angle 0. The another was very best estimate which you saw at the bottommost presentation of the previous presentation, which was V2 of 1 was 1.019 plus J 0.046. That is called as solution of voltage of bus 2 at the end of equation 1. So this is called very latest value of bus number 2 is referred in computation of bus 3 voltage. It is nothing but I am at bus number 10. When I am solving for V10 of 1, 10th bus voltage, when I am solving 9th, ready with me, 8th, ready with me, 7th, 6th, 5th, 1st, are they ready or not? They are readily available. So those ready best fit values if I use, rather than the flat start, 1 angle 0, 1 angle 0, again and again, number of computations that I need to perform to converge to a good solution and time involved in getting it converged automatically differs. When I use the latest value, it converges very faster. That is the power of Gauss-Seidel. Gauss use old value, Gauss-Seidel use latest value. That's the difference. Gauss-Seidel we are using. 3, 2. What about 3, 4? Have I reached the 4th bus? Yet not. I am at right now 3. So I have to use initial value. V4 0. You might ask me, what is wrong if I use V4 1? I may ask you, V4 1, is it there with you? Definitely no, because we are just at 3. 2 we have. 3 yet I am doing. 4 I have to do. Therefore, what the bus you are referring, 1 down to which we have latest, 1 up to which we have old. Old means maybe initial estimate. Likewise, it comes out. Now my next task is check. 3, 1. 3, 1 is here. what is this? 3, 2, 3, 4, 3, 3. I have this here. 1 by y, 3, 3 is here. 3, 1 is here. 3, 2 is here. 3, 4. All the connectivity has come here. Now I have to substitute the values and get me the solution. For that, I will substitute the values. How I do? Just I take out these values. What is y33? 1 divided by 3.666 minus j11 in bracket. Okay. What is P3 Q3? Can you see here? P3 is active power situation. What is generation? What is demand? PG minus PD I have to do. But for me it is given directly. What is the given value? Minus 0.1. What is QG? I mean Q total 0.5. So directly I will switch and place. This is minus 0.1 minus J 0.5. This divided by 1 angle 0. I just make it conjugate minus. This is V3 0 because the initial estimate of bus 3 updated value I am trying to get. What is the initial value? 1 angle 0 because I have never measured it in any earlier step. That is the step I am doing. Hence initial estimate is 1 angle 0 conjugate minus y31. What is y31? Bracket minus 1 plus j3 into V1 1.04 and angle 0 minus what is y32? Y32 is this minus 0.666 plus j2 into what is the value we got? The previous value we got 1.019 plus j 0.046. I have to check whether it is visible in your screen. 0.016. Yes, it is visible. Okay. And the last term is 34 minus what is y34? 34 is minus 2 plus j6. This into 1 angle 0. This is your complete step. You must note this is a change. This is latest value. This you must take care. This you must incorporate in your calculation. Clear? So now when I substitute all the values, I demand mathematically the product of these terms, V1 with the y31, V2 with the y32, V4 with the y34. When I simplify it and take 1 by y33, I will be getting the value of, therefore, V3 of 1 refers to the numerical solution of this. When I solve it, you need to work with the help of calculator, or if you are familiar with the MATLAB, you can put this command on the MATLAB window and you can work it out. There you have to use I. Instead of J, you have to use I. That you must know. If I operate it, I will be getting the answer 1.028. 1.028 minus J 0.087 pu. Now you might ask me, why you are putting in complex notation rectangular? What is wrong if you put in polar? Absolutely correct. I have to express this V3, whatever the value of bus 3 voltage in rectangular as well as in polar. So I will be having real and imaginary terms. When I put in polar, how it looks like? It looks like magnitude and angle. Magnitude and angle. This magnitude is nothing but the magnitude of 1.022 square plus 0.087 square under the root. And this angle is inverse tan of 0.087 divided by 1.02. How you get A plus or A minus BI or BJ? You can calculate the conversion of rectangular to polar. The first term represents magnitude. The term inside the angle bracket refer you the angular variation called as delta, which is nothing but, if I want to write, this will be V3 magnitude and angle delta, which is nothing but V3 magnitude, what I am trying to get, and delta, which is required. So this way you need to go. It's very simple but very lengthy, because I have 4 bus problem. Problem is still simpler. You can do it very systematically by having understanding. So hope there is no much change. Equation cyclically you need to represent, fill the blank with respect to suitable values of the y bus and table, and try to simplify. This is the process involved in making these things. So now I'll be able to get by this way V3 of 1. By this time what I did, V2 I got nothing but V2 delta 2 I know. Now I got V3, which is V3 angle delta 3. Now my next task is to calculate V4 and angle delta 4. There is no much change. The same thing, I just wipe it out, make the heading as V4 of 1, write the content pertaining to 4 and solve. Clear? Let me do it. So if I want to make this V3, I go to V4. So likewise, this work goes ahead. So mostly when you are able to see my notes, which are already shared, it will be convenient to you. Therefore, I write V4 of 1. What is V4 of 1? Solution of bus 4 voltage at the end of iteration 1, which is equal to, how do I write it cyclically? 1 by Y44 inside the bracket P4 minus J Q4 over V4 0 conjugate minus all possible connections. Now look into this 4th row. Do you have 4 to 1 connection? 4 to 1 connection? No. 1 to 4 connection? No. So if you want, you can write here. Otherwise you can skip. But I have a practice of writing the things which are possible over there, because there is no y present over there. Y goes by 0. Hence let me write here. This will be y41 v1 minus y42 v2 of 1 minus y43 v3 of 1. Let me make it bracket here. Now can you see over here? V2 of 1, V3 of 1 here. If I put in bracket, it will be more convenient to you if I want to make it like this way. What it refers? Bus 2 is already having the best solution. Bus 3 is also having the best solution here. I should not use 1 angle 0 over there. Which means to say, as I am moving further from bus 1 to 2, 3, 4, 5 like that, I will be having 1 down the number all. 3 I am working, 2 and 1. 7 I am working, 6, 5, 4, 3, 2 like that are already the best fit values at that iteration. We have to use them only. Only in the first step we will be using almost all the substitution flat start. Next iteration, next voltage you will be having minimum. Next voltage lesser than that, lesser than that, lesser than that. Likewise, your convergence is improving towards the best fit value. In that way, this we need to use. So I have to substitute best value of iteration value of V2 in the end of 1, best value of bus 3 voltage at the end of iteration 1 in this position. 1, 2, 3. Can you see here? 1, 2, 3. We have 1, 2, 3. Total 4, but this term is 0. This is 0. Can you see here? Y41. This is 0. This goes absolutely from a picture. You may not write it, but I have a routine making it notice and make it 0. It's very easy for me. So this will go by substitution as 1 divided by, what is Y44? 3 minus J 9 inside the bracket. What is P4Q4? Can you look into this? PI at bus number 4, 0.3 Qi at bus number 4 minus 0.1. So you have to be very careful about given the data in the problem which is repeatedly referred and used to obtain the unknown things. You shall not confuse by chance also. Otherwise you will be going absolutely wrong. Therefore, what is P4 for me? 0.3. This refers to 0.3 minus J minus of this 0.1. I write as usual. I will change whenever required. Otherwise, I will keep it as usual only. Then V40, fourth bus voltage, I am expecting first time, then his initial value must be 1 angle 0. Whose conjugate? Minus. I am dumping 0 here because it is no more a valid formula. 4, 1 is physically 0, this goes 0. You would have avoided this if you want really. Okay? Then minus. What is 4, 2? 4, 2. Second column, fourth row. This one. This is minus 1 plus J3, which is with the value V2. What is V2 of 1? 1.02. What is the value? 1.02. I refer from my code value 1.0 1.019 plus J 0.046. Okay. Then I lose minus the 1, 4, 3. 4, 3, this column. This is minus 2 plus J6 into, what is this? V3 of 1, latest value of bus number 3. What is bus number 3? In the previous write-up which we had, what was the value of V3 I got on the board? I got it as 1.028. This I got as 1.028 minus J 0.087. Hope you got to know what I did. P4 minus JQ4 from the table of given information divided by first initial estimate of variable 4. Outside the bracket I have 1 by Y44, which is from the Y bus. Next, the split terms, what I have to write, they are from connectivity. 4 to 1, is there any connectivity? No connectivity. 4 to 2, yes, we have Y42. Y42 from bus matrix, pick it, and when I have 4, 2 with the bus number 2, and it is latest value available for me because I am at 4th bus, 3rd bus, 2nd bus voltages are very much updated. I have to use them only. So it is 2nd bus voltage latest minus 4 to 3 connectivity, 4, 3, whatever I have here, minus 2 plus J6 into V31. Are you able to see here? V3 of 1 means very latest value of bus number 3. I have to write here and close the bracket. If there are many terms like this, those many terms I have to accompany inside. Then I have to finalize the term, simplify in a complex calculation, get the answer and obtain this value. Therefore, V4 of 1 stand as the value which I have the answer with me. I can present. You can definitely work it out. This is 1.025 and we have minus J 0.0093 per unit, which can be put as magnitude and angle, which is equal to V4 and angle delta 4. I can write this. So I have reached my problem's end. What was my problem heading? Obtain solution of V2, V3, V4, delta 2, delta 3, delta 4 at the end of iteration number 1 by conducting Gauss-Seidel load flow study was my target. So I have reached the requirement of which, hence I am able to solve this particular problem using flashcards, using Y-bus, using the equations which I have learned easily. But you have noticed this was a very simple problem as it do not involve generator. If it involves generator, what might happen? the generator voltage, before you calculate, you have to calculate reactive power ability. Check it for min and mag. It is valid, then go for voltage calculation. That is an extra step we have to do if it is pertaining to PV or generator bus. So that is not encountered here. We are just going ahead with the load buses, which is very simple, and it is cyclic kind of work we are doing. Hope this problem is clearly got to. And if you want, I can take one more simple problem on board only. Then we will lead the same problem which I have solved. I have a PowerPoint slide also, so which I will project to you on screen so that you can visualize this problem from the screen as well, which is readily for your observation. Okay. Before that, let me take you one more small problem which I work on board to make you comfortable. Okay. So let me take this. So I will take another simple problem which is with the load bus only. When I will mention all the data on the problem itself, which is still simpler to view. Okay. I'll take up another problem. So this complete problem I will take off. Hope many of you are observing it very clearly. You have to observe it carefully, because when you observe carefully, many things you will notice how things are getting turned around. Once you get that turn or changes which and when we have to do, surely you will be able to do given a chance. So this kind of problem you will be expecting in module number 1 in this particular syllabus. And module number 2 involves similar work, but notations are in, or solutions are by Newton reaction method. Okay. No matter, we'll work it out. So I will make another problem for you to understand this. Let us go ahead. I have one more problem which looks like this. Okay. I have a generator symbol mentioned. So this is all book to book. There is a presentation difference. No matter what is to be understood from that, we have to grab. Okay. So it is given as bus number 2, bus number 1, bus number 3. You have been given this as slack bus. Slack bus. V1 is given as 1. How much is given? 1 angle 0. 1 angle 0 PU. This is load bus. This is load bus. You have this as 10 minus, let me write in the lower, 10 minus J20 mho, and this is 16 minus J32 mho. This is 10 minus J30 mho. You have been given transmission line data in mho, means what admittance is mentioned directly. Then you have loads. What are loads here? Here load is 138.6 MW and 45.2 MVAR. Here I have a load 256.6 megawatt. And I have reactive power 110.2 MVAR reactive. Okay. So obtain solution to the voltage and angle of bus 2 and 3 at the end of iteration 1 using CSLF method. Use system base as 100. So this is the problem. The problem is given with the connectivity. You have 3 buses. Bus number 1 is a flat bus, which is a generator. Bus number 2 is a load, where you have P and Q mentioned. And you have a transmission connectivity from bus 1 to 2. And you have bus number 3, again a load, P and Q are mentioned. You have bus 1 to 3, a transmission line, and bus 2 to 3, a transmission line. So whatever is that, instead of giving you a table, can you make out the difference between the previous problem and this problem? In the previous problem, much of the things were given in the form of table of contents or put in the form of table. Now you have been put here in the form of representation on the diagram itself. Then you are said, obtain solution to the voltages and angles of bus 2 and 3 at the end of iteration number 1 using Gauss-Seidel load flow analysis and use system base as 100. Now this is an extra information. Why this 100 base of 100 is required? For that you should check. It is only to represent. Can you see over here? V1 is given in per unit. This is also more per unit. Already they are in per unit only. What is not in per unit? Why this 100 is given is only because of load. Can you see here? Megawatt, megavolt ampere reactive, both. So these things need to be converted to per unit. Only for that this 100 is required. It means this is equal to, now divided by 100 if I do, it becomes 1.386 pu. And after this becomes 0.452 pu. Clear? So this 100 is useful in converting this, and same is useful in converting these things also. What are these things now? This will be equal to, if I rewrite it, this will be equal to how much? 2.566 pu. What I am doing now? This 100, whatever is given in the problem, is taken to convert this power into per unit representation. Actual value divided by base value. Give me the per unit representation of the content which I am referring. I am referring to active power, reactive power, which are in the megawatt and megavolt ampere reactive at the system level, their bus level. And I want to make it common to the representation. The common base referred to the system is 100, what is given. Then I have to divide by 100. This would work as 1.102 pu. That's all. This is an extra work we have learned and will be doing it if at all values are given and base value is mentioned. If already they are in a per unit, like the previous problem, no need to do it. So this is what we have to take care. Otherwise, your computed values will be shifted by decimal. You will be having shifted decimal which look similar to your answer, but they are not the answer of my actual problem. This might happen in the exam. So you must be very careful about what is exactly the need of this giving base, where this is used to. If you know this, it's enough. So this kind of variety you need to be aware. Then once it is being done, converted, my system is very much ready now. Ultimately what I have to do now? Calculate V2 delta 2, V3 delta 3 are quotient. Then to do this, I require an initial estimate. To do initial estimate, if anything is mentioned in the problem, I should adhere. If it is not mentioned, I should use flat start. When I use the flat start, I should be using, so when flat start is used, so V2 equal to V3, I write here in the bracket here, equal to 1 angle 0 pu. It means when I use a flat start, it is these are the initial estimate for me. V2 is 1, V3 is 1, delta 2 is 0, delta 3 is also 0. I don't know whether these will stand good once I complete my iteration, or will they get changed, which messes me at the end of the iteration only. Therefore, when I use a flat start, I must use this thing. That's the first thing. Once if I do this, I have to frame Y bus. Because you might ask me, why you require Y bus? I can do it visual by looking it. No. In the process of calculation of load flow, you have been allotted some specific marks to the Y bus itself. In that due regard, framing of Y bus is very necessary. With a vision, with a rule of inspection, you can write the V2, V3, V4 equation, however applicable, very directly from the observation if you become familiar with the problem. But that is not the issue. It is required as a systematic approach. Hence, I have to form Y bus on this. When I want to form a Y bus, take one more care. Is the data in the problem is in impedance or admittance? If it is an impedance, what is the next step? Convert each impedances into admittances without fail. Then work for Y bus. Otherwise, mere impedance what is given, you consider by mistake them as an admittance, solve your problem. I'm sorry. You have solved a problem which is not intended. You might be correct, but they are not my matching answer. For a wrong problem, you might be correct. So it should not happen. That's the reason, observe the question carefully, very keenly. Is the data what I am referring in this problem is specific to my requirement or not? Have I took the question paper content to my paper appropriately or not? Once you confirm it, you may leave the question paper, start working on your answer booklet. Otherwise, just ignorance of 5 to 6 seconds will spoil your entire 10 to 15 minutes of work, which is a problem which is wrongly destined, which will be wrong, absolutely wrong. So therefore, take care. I'm sure all are in Mo, I have no doubt. Therefore, what is the system size here? Y bus size? Y bus will stand as here. Is it 3 cross 3 or 4 cross 4? It must be 3 cross 3 because the number of buses in this problem are 3 and Y bus stand as 3 cross 3. If I am not wrong, if I start working upon Y bus and this lower plane itself, so let me write here only. So Y bus is equal to 1, 2, 3. Let me make it 1, 2, 3. A wide area I'll refer. I just make it. Okay. Now what is 1 cross 1 here? Sum of the admittances of the lines going from bus 1 to rest. I have 1 to 2, 1 to 3. Add these two in admittance part. Add them, place here. What is this? 10 plus 10, 20. 20. And minus 30, minus 20. It is minus j 50. So it is nothing but addition of these two. What is 1 cross 2? Elemental data, what I have 1 to 2, negative of that. What is this? 10 minus 20, negative. It becomes minus 10 plus j 20. Hope you are able to write it directly. Then what is 1, 3? 1, 3 is negative of this data, which is minus 10 plus j 30. You please keep watching what I am exactly on the board. 1, 3, negative of the admittance between bus 1 and 3. 1, 2, negative of the admittance between bus 1 and 2. 1, 1, sum of the admittances of the lines going from bus 1 to remaining side. There are 2 lines, add those 2 and place them negatively in their respective position. This is row number 1. I go to bus number 2. I stand here. How many lines are here? 1, 2. What is Y22 for me? Y22 is sum of these two. What is 10 and 16? 26. So 2 cross 2 at this position. 2 cross 2 is sum of these two. 10 plus 6, 26. And it is 20 and 32 minus j 52. It is y 2, 2. Add these two, place them here. What is 2, 1? Out of this, what is connected to bus number 1? 2 to 1. What is the value? 10 and j20. Negative of that. Nothing but pick and place here. Pick and place here. Minus 10 plus j 20. Hope this is clear. Hope you are following me. What about 2 cross 3? Bus 2 to 3. What is the line available? 16 minus j 32. Whose negative data? Minus 16 plus j 32 will be the position here. It is minus 16 plus j 32. Hope this is clear. Negative of the admittance between bus 2 and 3 is 2 cross 3. I wrote it here. Now I should move to bus 3. At bus 3, how many lines I have? 2. 3 to 1, 3 to 2. So 2 lines. 10, 16, 26. 3 cross 3, I write here. 26 minus 30 and 32. What is this? 30 and 32. Am I right over here? 30 and 32. It is 62. J 62. It is 10 and 16, 26. 30 and 32, 62. Which is 3 cross 3, diagonal element. What about 3 cross 1? Element number which is there between 3 and 1. 3 to 1. What is the value? 10 minus j 30. Negative of that. Nothing but copy, paste here. Which is minus 10 plus j 30. What about this line? 3 cross 2. Bus number 3 to 2. What is number 3 to 2? This element. 3 to 2. This element. Negative of which is readily available here. 2 to 3 same as 3 to 2. We can place here. Which is minus 16 plus j 32. Hope my Y bus is very clear to you all, because I did it very easily, because I could do by method of intersection method. By knowing the size of the Y bus, 3 cross 3 over here, there are total 9 elements. So must confirm yourself they are in admittance, then I will be able to do this. Hope this step is very clear to everybody. This is the foundation, because if I go wrong here, imagine what is the V2 of 1? 1 by Y22. There you use it inside the bracket. Y21, Y23, Y24. Where you use it? From the Y bus only. If this go wrong, basically, I am 100% sure your problem will be wrong. So therefore, seriousness must be there when you form mathematical formulation of Y bus. If it is correct, your errors are reduced. So conically, you will reach the destination step by step. Now, once if I am ready with Y bus, having all this data converted, may I know what is my next step? What are my unknown? Calculation of V2. What is V2? What is delta 2? What is V3? What is delta 3? These are my unknowns. I want to calculate them. Basically, I am trying very first type of problem. I am not trying to get transmission line loss. What are the active power flows? Nothing I am working. What is the complex power supplied by the slack bus? I am not at all touching. I am just trying to use the method of Gauss-Seidel, how it is used. Then we will look into complex situations. Therefore, after having understood it, let us put ourselves what is V2, V3, delta 2, delta 3. Therefore, I write it is V2 of 1 is equal to 1 by Y22 inside the bracket. Let me write here P2 minus JQ2 divided by V20 conjugate minus Y21 V1 minus Y23 V3 0. So please verify my equation whether I have written correctly or not. Okay, P2, Q2. Now my question is, what is P2? What is Q2? You have to check. Now my question again to you is, how do you write P2? P2 is nothing but Pi. Pi is nothing but Pgi minus Pdi. What is this Qi? This is called Qi. This is again Qgi minus Qdi. You please note this write-up which I did on the board. which is very necessary for you to understand. In the previous problem, I have not been given any generation, any demand. Simply I have been given Pi and Qi, which readily I dragged and dropped. But here it is not so. You have to be very careful about understanding what is the situation of active power at bus 2, reactive power at bus 2. How it should be done? Like a Pi. Pi was given to you in the previous problem. But here Pi is not given. What is given to you here in this problem? 256.6 or 2.56, whatever so value. 2.566 value is given to you. So what this 2.566 value is noticed to you as? It is noticed to you as the active power demand. So this active power demand is nothing but the demand which is D, not the G. Now, why this matter to you? It matter you because you look into this. Pi refers to PGI, PDI. If PGI is 0, what it refers to? Minus of PDI. Whatever the term you are supposed to write here is no generation, only demand. That demand is minus. I would otherwise say the value over here is, if you look this, 256. I wrote, I think, bus number opposite. So can you, yes, I am correct. Bus number 2 is 2, bus 2 is here only, correct, I am correct. So P2 refers to, there is no generation, only demand. It is 0 minus 2.566. It could refer now as minus 2.566. So this correction I have to do here in this type of problem, where you have not been given active power situation, you have been given demand only. Then when demand is given, PG is 0, 0 minus the demand refers to minus. So similarly reactive power situation is Qi. Qi was given in the previous problem directly, but here it is not given, reactive power is given. Hence it is any injection, any demand is called reactive. Let me write the value, you will be able to cope up. This will be 1 divided by, what is Y22 for me? Y22 refers to 26 minus J, 52 inside the bracket. It is P2, which is 0 minus 2.566 minus J. Let me write first time, later you will be able to understand. 0 minus 1.102. This divided by 1 angle 0 conjugate minus. Okay. Now you make out the things here. PG minus PD. PG minus PD. But you have been given PD, QD. PG, QG. Both are 0. Hence it becomes negative of the load mentioned. Naturally, this term will be positive because there is a negative outside, negative here. That will not worry. We will worry about the exact term. PG minus PD is my requirement in the position of P2. QG minus QD is my requirement in the position Q2. That's enough. Y minus Y plus will not worry because automatically it is going to change its and sign if it is a load or if it is a generator. Will not worry, but you will understand this concept. This concept which I have focused on the board is very necessary. You have to look with this angle only. Is the data in the problem is given directly QI, or do I need to work out PI, QI? You have to question yourself and go next. Here you may go wrong. Therefore, in this problem, I am probing you to check PI, QI for personal calculation. Earlier it was directly given to you. So therefore, take care of these things. So then it's very simple. What is Y21? Y21 is element number 1 in the second row, which is minus 10. This is minus 10 plus J20 into, what is the slack bus voltage? Slack bus voltage is 1 angle 0. This is 1 angle 0. Minus, next term, Y23. We have a term here. 2 to 3 there is a connection. Y2 3 is here, which is minus 16 plus J 32. And what is V30 conjugate V30 for you? When I refer flat start, where I wrote it, I take off. Flat start. When is the initial estimate of bus 3? I haven't gone to 3, I am still at the 2. Hence, this initial bus voltage goes 1 angle 0. So, these prerequisites you must be careful. If you are careful about these prerequisites, you are going to land on exact answer which is expected. Otherwise, quite sure, you may change or you may go wrong, which you find I am correct. Therefore, justifying ourselves is very necessary. So, therefore, when I solve this problem, complex situation, I'll be having V2 of 1 as my solution. If I am not wrong, the V2 of 1 value which I have here in my note, which I'll be showing you. The same problem is there with me PPT. I'll show you. 0.9633 minus J 0.00310 per unit. Work is very simple, but making it to come true is the intelligence how we have to practice. We should look. So for that, systematically observe, form, use the equation, substitute the content, mathematically get accuracy and stop. This is what you have to do. This you put in polar form, which is equal to magnitude and angle, which is equal to V2 magnitude and angle delta 2. So I have not done in polar form. I request you, please look with angle of polar conversion. When you convert it to polar, I will be having magnitude of V2 as well as angle delta 2. So this is my standing point for bus number 2. How about bus number 3? There is no change. Same process I have to continue. Numerically, I have to put the thing and get its real value. Hope I am going very clearly in a systematic way so that you are able to track me and you are following. Then if I follow the same steps for bus number 3, how would I change my steps? I take off, I write the equation for V3 of 1 equal to, I substitute the content, I go ahead. Let us do that also. So after having V2 of 1, I take out this, I go to V3 of 1. Solution of bus 3 voltage at the end of iteration number 1. So I write V3 of 1, which is equal to, if you follow me, 1 by Y33 inside the bracket P3 minus J Q3 over V3 0 conjugate minus Y31 V1 minus Y32 V2 of 1. You must be very careful what I am writing on the board. This is V2 of 1. It is V2 of 1 because bus 2 got very best value compared to its initial estimate in the previous workout. That value only I have to use. So if I substitute the values, let us do it. This is 1 divided by Y33. What is Y33? The value of 3 cross 3 element is 26 minus J62. 26 minus J62 inside the bracket. What is P3 Q3 for me? You look into this. Is it a load or generator? Load. Is there a generator? No. It is again, I use this as PG3 minus PD3. This I use as QC3 minus QD3. You notice. So there is no generation. Only demand here. Only demand, only demand. Then, no doubt, it will be 0 minus the value of 1.0 386 minus J 0 minus 0.452. This divided by 1 angle 0 conjugate minus, you look step by step, PG3 is 0, PD3 is existing, QG3 is 0, QD3 is existing. I am substituting term by term because it is our first problem. When you go with the next subsequent problem, you can take off or relief over here. You can do it, it is easier. So what is Y31 for me? Y31 is 10 minus 10 plus J 30 into V1. What is V1 for me? V1 is 1 angle 0. 1 angle 0 minus, what is your next Y32 term? 32, this column, 16, 32 minus 16 plus J 32 into V2 of 1, the best solution of voltage of bus 2 in the previous step what we obtained, which we obtained as a value 0.9633 minus J 0.0310. So this is called latest value of V2. V2's value, not 1 angle 0. 1 angle 0 was referred in the first step of V2's solution. V2 is complete, hence its best value is available. Then I will be using its best value in the computation of V3. Therefore, when I arrange 1 by Y33, P323 by V30 conjugate minus Y31 V1 minus Y32 V2 of 1. So-called possible terms as per the connectivity. I have 3 buses, I could land this much only. Then if I simplify this answer, what may be my answer? My answer stand here with the numerical data, which is 0.9674 minus J 0.0342 pu, and this can be, this is V3 of 1, which is equal to magnitude and angle, which is equal to V3 magnitude and angle delta. So we have come to the end of the problem. So easily. This is how numerically we need to work very carefully with the problems. So this kind of problems, when you solve repeatedly, you will be in a position to work it out. Now I suggest you people, look this same problem, whatever just I did on the board, which is very simple. Only you change this value to 1.05. If I change it 1.05 and angle 0, V1 1.05 angle 0. Don't use this. Can you solve this yourself? You can, because wherever there is a 1 angle 0, now this will be 1.05 angle 0. You will have a different problem yourself. Or you can change the elemental data. You will get this Y bus different. That all numerical be same, only Y elements are different. You can still work yourself. Or you can still change PQ of this, of your known value, which you can justify by your understanding. This way you need to work confidently. For you, what is my suggestion? From the textbook, whichever the problems available, whichever the problem we are interacting, whichever the problem I am going to share to you as an educational material from different books collection, I will share directly to you for the academic purpose only. So I have put a watermark there. only for the academic need from the different books. So when I use them, you get lot of ready to go numerical solutions. Only you need to get competency how to get those solutions. That's enough. You can definitely solve any number of problems, whichever comes to your face. So therefore, this way you can look forward for changing the values and working for the numerical. So I just would like to see, is my problem interaction is going comfortable to you all? Someone in the group? Is the problem discussion is going comfortable to you all? Okay, fine. So one of your friend has replied to me. So it's very easy. I would otherwise say, if you are familiar, model number 1, these are the type of problems you have grabbed 8 to 10 marks at your credit. I would otherwise say straight on the face. So grab this, and theory discussion what I have done and numericals which I am going to share to you much more will be helpful to you. So I will take one more problem, one or two more problems with the PowerPoint extension, because the same problem which I have solved on the board is readily available in PowerPoint as well as in PDF, which I am going to share to you. Okay. So now I am switching to the PowerPoint slide and I'll take you with that launch. Please be with me. I am going to share it. Hope my slide is visible to you all. Someone please reply to me. Because I am on PowerPoint slide, I will not be able to see your chat messages. Could you orally tell me it's visible to you? Example 1.
Yes, sir, visible.
Anyone please? Visible to you?
Yes, sir, it is visible.
No, someone is trying to connect me, but there is an audio disturbance. So, am I able to present this slide to you? I just come back and see. Somebody in the box, am I able to present to you? Yes, okay, fine. Thank you very much. I am there. Okay. No matter how many of you are there, your attendance is going to be taken automatically. That justifies me. Okay. Yes, I am launching. Yes, I am here. Please look into this problem, which looks like the problem just now I have discussed with you. There are 3 buses in this problem. Bus number 1, a slack bus where generator like circular symbol is shown. Bus number 2, there is a load. 2 arrows are mentioned, active power, reactive power, like that. These are load. Arrow shows load for you. Bus 3 is also load for you. And you have a connectivity from bus 1 to bus 2, bus 1 to bus 3, and bus 2 to 3. But be very sure, the data mentioned in the problem, in the text, it is impedance. It is not admittance. It is impedance. And slack bus voltage is given as 1.05 angle 0 pu. Then you have loads at respect to buses given in megawatt and megavolt ampere reactive. And you will not read much of the problem. You will just see this is a problem with all the information for me to obtain solutions of voltages at bus 2, bus 3, angle of bus 2 vector and angle of bus 3 vector. Base of the system is 100. You can just, this is sufficient for me to get to the problem. You have 100 as a base. I was speaking in the previous problem on board. Base 100 MVA refers here just to convert powers into per unit. You should not divide impedance 1.01 plus J03 divided by 100, 1.0125, whatever so. Not to do that mistake. All the values are at per unit, ohmic or mho. Only not per unit is power. Only you have to convert power to per unit. Then you should check whether the given data is in impedance, I have to convert to admittance. If it is already in the admittance, you should go next. From this, I understand that there is one generator which is a reference bus. There are two loads, bus 2 and bus 3 given with the load values. Now my work is to continue with the load flow study, obtain voltage solutions of bus 2, bus 3 and also just see there, determine the line flow, line loss and slack bus active and reactive power, real and reactive power. How much is the power delivered by the reactive power to meet the loads at bus 2 and bus 3 as well as transmission line losses, because there is no generator other than slack bus. That is the only generator has to fulfill the load as well as take care of losses. How much is the power supplied by that has to be calculated. Now look into this. Looking to the earlier problem which we worked on the board, this was not discussed. What is not discussed? Determine line flow, line loss. I have not discussed, but I will be doing over here. And determine the power supplied by the slack bus to the system. I have not done. I will do it. It means whatever the work we have done on board need additional involvement of ourselves to get to these things. We will see how it can be done. So, having seen this problem, I move to next. That is drawn. This problem is simply drawn as 3 buses in a single line diagram and line data were represented like this. Now, can you see over there? Line impedance is converted to admittance. 1, 2. The value is 1 divided by 0.02 plus j 0.04 is impedance converted to admittance. Now, can you visualize something here now? Was this the problem I have solved just now before this PowerPoint discussion? Yes. This was the problem I have used in different book perspective. What I am presenting to you is from same problem from other observations from the different author. No matter how author view it, it mattered to me how to solve. So, data was given in my problem admittance. Now it is given impedance. So conversion is mandate. It is being converted. You can see that it is being converted, readily put on the transmission line. 10 minus J20, 10 minus J30, 16 minus J32 and mentioned the powers as well. Now my next step is what? Divide these powers divided by 100 and keep them as ready to go complex power, like active and reactive power. For that, what has been done? Can you see there? So, in the footer of the slide, S2 scheduled, S3 scheduled. What is this exactly the keyword by some author? It is calculation of P2 Q2, P3 Q3. Can you see over here? What is P2 for me? P2 is 256.6 divided by 100. That is 2.566, which is active power demand. Is there any generator there? No generator. 0 minus 2.56 refers to minus 2.56 directly over there. Can you see this step? What the author has done? Author has done this calculation as load at bus 2 is taken inside the bracket. How it has done? 256.6 plus J110.2 divided by 100. Outside there is a minus. What this minus refers to? 0 in the active power generation, Pg, 0 in the reactive power injection, Qg. When I make subtraction, this will definitely become the term which is expected. Therefore, it is directly written in this form. You will see how it is being used. Even I may not discuss this. This will be done in the next slide. So, it is an work some people do very specially about power calculation. You need not worry about this. If you know this, divide by 100, divide by 100, keep ready. And when you want to do V2, V3 equation, P2, Q2, P3, Q3 you require. There you can do numerical differences directly. Okay, no matter how it is being done, you will just observe, because books when you refer, you must be familiar to their notation. You shall not say how you do it. It is their one approach. If you have done it, yes, accept it. And you have concluded to the same answer, you have to appreciate them. In this way, you will understand very easy PG minus PD, QG minus QD as my simple approach, which is similar to this approach, which lead me the numerical values. When I move next problem, next slide, just see here. It's been taken. What is this? Bus 1 is taken as a reference, which is a slack bus. What is the voltage given for that? Voltage is given 1.05. I go back and confirm you. 1.05. Slack bus voltage given as 1.05. Then other two buses, V2, V3, I have to calculate. Delta 2, Delta 3, I have to obtain. Then for them, I require flat start, which is given here. When I use initial estimate from initial value, 1 plus J0. Can you see here? V2, 0. V2, 0 is 1 plus J0. It can be 1 angle 0 also in the polar form. No matter. 1 plus J0. V3 is also 1 plus J0. They are called as initial estimates of voltages. Similarly, now look into this presentation. What is the equation I referred? V2 of 1 is equal to a square bracket. Entire square bracket is divided by Y22. Can you see over here? Y12 plus Y23 in the grand denominator. Just see the large horizontal line below which you have Y lowercase Y12 plus lowercase Y23. What these two refers to? Small case Y12 elemental admittance, small case Y23 elemental admittance. If I add these two, what it results to? Go back to diagram. At bus 2, what is Y12? This term, 10 and 20. What is Y23? 16 and 32. If I add these two, what I will get? Capital Y22. That is what the author has done. Instead of writing capital Y22, he wrote it in steps. Now before this, you recall that what we were doing? We were doing Y bus by instruction method for our immediate use. This author has not done Y bus. He concluded in stage, in line, what is required, he did it. So therefore, be very clear what is the notation he referred. The author referred lowercase y12 plus lowercase y23 refers to capital Y22 for us. You can look at the denominator. It is 26 minus J52. 26 minus J52 nothing but the diagonal 2 cross 2 in our old problem, which I did on the board. The same thing is here. How about the first term? The first term is P2 minus JQ2 divided by V20 conjugate. What is this term? P2, PG minus PD. PG minus PD means 0 minus 2.56. Is it minus 2.56 here? It is there. Minus J outside. Originally, minus J outside. Inside a small bracket 0 minus 1.102. That minus automatically becomes plus over here. It is P2 JQ2 divided by V20 conjugate. What is V20 originally? 1 plus J0. Conjugate refers to minus J0. So we could get the first term here. P2 minus JQ2 over V20 conjugate. What was our second term? We had minus capital Y21. Hope you remember it. Minus capital Y21. Minus is witnessed because Y21 was capital term obtained from Y bus. Y bus of diagonals will always have negatives. Hence, to cancel that negative, one negative was referred in the derivation. But here, what is the author's style of writing? Plus. Plus 10 minus J20. What this 10 minus J20 refers to? Elemental admittance. I go back to the previous slide. What is 10 minus J20? Elemental lowercase. Lower Y12 is 10 minus 20. What is the difference between capital Y12 and small y12? Capital Y12 is minus of lowercase y12. If it is minus 10 plus J20, here one minus should come outside. That is taken out. They have written directly in lowercase y12. This is the difference in writing of type of terms from author to author. So you should not get panic of this. You must understand the notation of the problem and you need to understand. Hence, instead of minus wherever I was speaking in my on-board presentation, capital notations of admittances I referred from Y bus. But in this problem, author is not preparing Y bus. He is using from his knowledge directly elemental representation. Hence, wherever I have minus, he will be having plus. But answers will be the same. There is no matter. It will be very close to what we got. So therefore, when we substitute the first term y21 and v1, 1.0500. Minus add a row here, now it's plus. Then it is 2 to 3 into v3 initial divided by y22. So this if you simplify, so 0.9825 minus j 0.0310 pu is your answer. So this is how very close answer I am going to get from consideration. Okay. So once I get this answer numerically, I will be using it in the next step. What is my next step? V3 of 1. What is V3 of 1? P3 minus JQ3. Just observe the numerator of the term. P3 minus JQ3. Nothing but 0 minus demand minus 1.36 minus 0 minus the reactive power 0.452. That becomes plus 4 there. Divided by V3 0 conjugate, initial estimate of V3, 1 angle 0 or 1 minus J0. Similarly, 3 to 1, Y31, you have to multiply with V1. You can see there, I go back, Y31, V1 plus Y32, V2 updated. Can you see this? 0.9825 minus J. This is the previous solution here. It is Y32 V21. V21 means latest value of V2 bus. So it is taken. Entire term divided by Y22. Sorry, Y33. Then I will get the solution of bus 2. This is how we got V2 delta 2, V3 delta 3. Suppose these data are not acceptable to you. Suppose you have a criteria called voltage convergence. Voltage is not within the range. You have to repeat the work. By chance, you have taken second iteration. So same kind of calculation you would do. For us, it is not there, but just a glance. For iteration 2, V2 of 2. See the notation. Earlier it was V2 of 1 here, first pass. It is now V2 of 2. So you can see here how it is being changed. So in the third, we just observe for the particular thing, numerical Y21, Y23 remain the same, but magnitude of voltage will change. P2, Q2, has it changed? It has not changed. Denominator of that, V2 0 conjugate, it was initial, now it is no more initial. You have V2 already obtained in the iteration number 1, which was 0.9825, is positioned in the P2 minus JQ2 divided by V2 1 conjugate, not V2 0 conjugate, it is V2 1 conjugate. You can see there 0.9825 minus was there, now it's becoming conjugate means plus J 0.0310 plus same term as usual in the first line plus same term. Here there is a change. What was originally here? 1 angle 0 or J0. Here it is just obtained best value which you are going to use. If I solve, you would see here, first time when I solved in iteration number 1, V2 was 0.9825 minus J 0.0310. When I complete the second iteration, it is 0.9816 minus J 0.0520. It is changing the value, but falling very close to each other. Likewise, V3 of 2, second pass of V3, if I substitute, I will get. Likewise, third iteration, fourth iteration, fifth iteration, I should go. How long? As per the criteria mentioned. So, I will be going like this. You can see here. As per the process of convergence accuracy of 5 into 10 to the power minus 5 0.000 zeros, 0.405. That is the accuracy. He is expecting after the decimal sixth position 0.0000 and fifth value is 5. That is the error he expects. Rest all values come reject and go next, reject and go next. In that regard, the solution has taken up to 7 iterations. Can you see here? Third iteration, fourth iteration, fifth iteration, sixth, seventh. At seventh iteration, the error between sixth and seventh is just confirmed. Very, very close to each other. In that way, seventh iteration is acceptable. Don't worry, you are not supposed to do this. It is computer generated information. For us, just a knowledge. Similarly, V7, V3 of 7. Then final solution, it is taken out. Can you see over here? The seventh iteration value. Suppose for me in the exam, after one iteration, what is obtained in the first iteration? Only I have to write. That is like this way. V2, V3, rectangular, polar. This stands as V2 magnitude, angle of the delta 2. V3 magnitude, angle of the particular V3. This is what we have done already. Now what is extra here? Slack bus power. How much power did slack bus injected into? So I go back to the diagram. What is the power injected by this? V1, I1 conjugate. Complex power injected by this slack bus is bus voltage V1. Current what is injecting? I1. What is I1 for you? I1 is I1 to 3, I1 to 2. If I have a current flowing out of this, I1 2, if I know, I1 3, if I know, add them, that becomes I1 for me. So what is I1 2 for you? V1 minus V2 into admittance of this path. Give you I1 2. What is the current I1 3? V1 minus V3 into Y13. Current through this. Add these two currents. That becomes bus current 1, I1. Like a KCL. Then V1, I1 conjugate is nothing but complex power injected from this slack bus. That is being shown here. You can see it. V1 conjugate and the current. This is nothing but VI conjugate. You may split it up. What is this exactly? You can see here. It is written as V1 outside, Y12 and Y12. You just take first and first term. Y12, Y12. What is common here? Y12. V1 minus V2 into Y12. V1 minus V3 into Y13. So arrangement is done by order of V1, V2, V3 to solve numerically in the computer. So it is actually V1 minus V2 Y12. Current going towards bus number 2, I12, as well as V1 minus V3 into Y13. Current going towards bus number 3. If I add those two, that becomes bus current. This square bracket, what is there? Nothing but current I1. So VI conjugate. Of which conjugate if I take, I am going to separate real and imaginary terms, which is being done. So first term is real power injected, second term is reactive power. If I calculate and do it, how much is the active power? 4.095 per unit. Reactive power is 1 this unit. Okay, so active power, reactive power is calculated. So 409 megawatt is pumped and 189 megawatt ampere is pumped. Now I will take you back 409 and read the problem. What is the total power here? 138 plus 256. If I add these two plus the loss happening in the system is the power pumped by active power by slack bus. 256.6 plus 138.6 plus transmission line loss is nothing but total power supplied by the slack bus, which is nothing but this one. Similarly, reactive power. If I want to separate the losses, you can see here, we calculate current flowing from 1 to 2, V1 minus V2 into Y12, which already he has used, he is writing separately. What is Y21? Opposite to this one, minus of I21. What is Y13? I13? V1 minus V3 into Y13. It is being done here. Very clearly shown. I12 plus I13, nothing but I1. Likewise, so many currents flowing. All those currents if I use to calculate complex power flowing from bus 1 to 2, 1 to 2, S12, V1, I12 conjugate, S21 reverse, V2, I21 conjugate, S13, S31, S23, S32. I am able to do it. It was discussed very explicit on board for the complex power. When I substitute the values of respect to bus values obtained, currents which I calculate from this kind of numerical interaction, I'll be able to get a total at complex power flowing towards 1 to 2, 2 to 1. If I find these two addition, S12, S21, if I add, it becomes 0, it is called lossless line. If there exists some difference, what is the difference? That is the loss in the section that I want to show you in the next slide. So, once I know the current flowing in each section, I can calculate complex power running on each of them, forward and reverse. When I know forward and reverse, I can get losses also. So, in this way, I can go next. So, this is a problem. We will stop here. And similarly, I have one more problem which would focus you how calculation will be taken for such numerical values. In the next class, we go ahead with this, and I have two more problems, and we'll see to that we are able to get them. Okay, I just stop.